Jai Hind everyone, I am Pankaj Kumar and this is a series of the video for the amino acid metabolism. So if you didn't see my previous videos, please go through that previous video. That is a continuation of this lecture. So in this video, we are going to see about how three things we'll see. First thing, the damage in the liver. Okay, so liver will be damaged, then what are the signals? Then what are the assays you will do? Okay, second, you will see the regulation of urea cycle. Regulation of urea cycle, and third you will see some disorders. So if the liver will be damaged, so what will be the important enzymes you will get? So whenever the liver will be damaged, mostly the enzymes which are in the urea cycle that you will get abundant in the blood. So you will do the GOT or the ALT as a your assays for your diagnosis. So blood level of the alanine aminotransferase, which is known as a ALT, or also called as a GPT, glutamate pyruvate transaminase, and the aspartate aminotransferase. So ALT is also known as a GPT. Now, alanine aminotransferase and the aspartate aminotransferase also will be the very important role for the diagnosis of the liver damage. So whenever the tissue will be injured by any infection or by overdosing of the drug, it can be any drug, so you will get more abundant amount of these enzymes in your blood. So if you'll do the SGPT or SGOT, as you know, SGPT is what? The glutamate pyruvate transaminase, and GOT means what? Glutamate oxalate transaminase. This is the uh, another name of the ALT and the AAT respectively. Now there is one more enzyme, the keratin kinase. If you want to see the level of the keratin kinase, you have to do the SCK test. Can provide the information or about the severity of the damage. So this damage will be tell you about the more important things like by which chemical it is happened. So it may be liver damage can be occur because of the occupational medicines, or to determine whether the people is exposed to the carbon tetrachloride or chloroform or other industrial solvent have been suffered the liver damage. So by this statement you can understand the occupational medicines also can do the liver damage, so we have to be in check. Now how the urea cycle will be regulated, remember it. So urea cycle have the most important enzyme which is called as the carbamyl synthetase. What it is? Carbamyl synthetase. So as you know, we already studied this urea cycle. In that we seen carbamyl synthetase will convert the NH4 plus into the carbamyl carbamyl. Okay, this is carbamyl synthetase 1. There is one, another is there, carbamyl synthetase 2, which is in the cytoplasm, and that will be helping in the purine pyrimidine synthesis, not in the amino acid metabolism. No. So usually in which it have to be regulated whenever more ammonia will be there, we need this carbamyl synthetase more, and this carbamyl synthetase is regulated by the one enzyme which is called which is regulated by the N-acetyl glutamate. So this carbamyl synthetase one is a allosteric enzyme. in allosteric site, if N-acetyl glutamate will bind, then only this carbamyl synthesis will be going to be activated. Once it will be activated, then it will convert the ammonia. It will convert this ammonia into the carbamyl. This is the important step. Now this N-acetyl carboglutamate, from where it is formed? How it is we can form this N-acetyl glutamate? So this N-acetyl glutamate is regulated by the acetyl coenzyme A and the glutamate. So we are fortunate because in our case, the N-acetyl glutamate synthesis uh, activity in the liver has purely regulatory function. So N-acetyl glutamate is directly converted by the glutamate. So we don't have to convert the glutamate into the arginine. But in case of the plant and microorganism, the glutamate can this N-acetyl glutamate synthase can convert the glutamate also in the arginine. So there is a two role in the plant and microorganism. But in our case, the N-acetyl glutamate synthase will form only the carbamyl N-acetyl glutamate. Okay. So N-acetyl, three things we studied: the acetyl coenzyme A or glutamate and glutamate will give you what? It can give you the N acetyl glutamate in the presence of this enzyme, N acetyl glutamate synthase. So what you found? What is the important take home knowledge from here? The glutamate, if the glutamate will be more, then N acetyl glutamate uh, synthetase will be more, and then carbamyl will be more. Okay. So and the arginine, here we can see arginine, an activator of N-acetyl glutamate synthase and thus activator of the urea cycle. You remembered it. Arginine is the activator of urea cycle. Why arginine is the activator of the urea cycle? Anybody can tell me the answer in the chat box. Okay, so the arginine is the important because in plant and the microorganism, the glutamate also converted into the arginine, also converted into the arginine, and then this arginine will become the part of the urea cycle. Where it will become the part of the urea cycle? It will give you the ornithine. It will give you the ornithine. Okay, by that way you can become the part of the urea cycle. Okay, now this is the illustration which is already explained above, as I said. So carbamyl phosphate synthesis 1 will convert the ammonia into the carbamyl phosphate, and here you require this N-acetyl glutamate, which is the allosteric substrate for the enzyme synthetase 1, and finally you will get the carbamyl. Important thing is that you need glutamate or the acetyl coenzyme to produce this enzyme. So this is the important thing. Now how much ATP you formed in the urea cycle. This is the very important. Okay, so you remember only 3 ATPs you required. So can you guess where these 3 ATPs are required? So the first ATP you will required into the conversion of the NH4 plus into the carbamyl phosphate. Here you required how many ATP? Here you required 2 ATP. Okay, and one more ATP is required where? Anybody? Into conversion of citrulline AMP to the uh, citrulline MP to the arginosuccinate. Okay, arginosuccinate. So arginine will be also help in the this step also. So 1 ATP here. So total 3 ATP is required. You remember this energetic diagram? Now the defects, as we said in the videos. So the what are the defects are occur because into this urea cycle. So major defects are because of the lack of the enzyme. So what are the lacking of the enzyme? Whenever the lack of the enzyme will be there, so you will find the edema or the lethargy or the hyperventilation or the cerebral edema, like cerebral edema. So what is happening if there will be no enzyme? Any enzyme you can take carbamyl phosphate synthesis 1. Okay, carbamyl phosphate synthesis 1. If this enzyme is not there, if this enzyme will be not there, then what happen? If carbonyl phosphatase 1 will be not there, then finally what is happening? The NH4 plus will increase. If NH4 plus will be increased, it will become more toxic. If it will become more toxic, then edema or the lethargy, hyperventilation, this type of things will be occur. So what we have to do? We have to reduce this ammonia by any way. So either two things we can do, because this required glutamate or the it required arginine. Okay, it required arginine, glutamate. Okay, glutamate, or sorry for my handwriting, glutamate and acetyl coenzyme. These things it required. So if it will provide this, then it will be cured. Okay, uh, then acetyl, sorry, then that enzyme, then N-acetyl glutamate will form, and this N-acetyl glutamate will form the will activate this carbamyl phosphate synthetase 1. So that is the important thing. Otherwise, what we can do, we can add this ammonia with the artificial chemical in form of the medicine like benzoate. Okay, so once you'll add with the benzoate, so benzoate will converted into the benzoyl coenzyme. So can if it will form the benzoyl coenzyme which combine with the glycine to form a hypurate. So hypurate it will form. Another enzyme is that phenyl butyrate. If we use the phenyl butyrate, so phenyl butyrate will converted to phenyl acetate by beta oxidation. So the phenyl acetate then converted into the phenyl acetyl coenzyme which combines with the glutamine to form a phenylglutamine, and phenylglutamine is not a toxic. So these two things are very important to remember it. So here we'll see where it is. This is the benzoate. It will bind with the coenzyme A and then it will form the benzyl coenzyme A. This benzyl coenzyme A bind with the glycine and it will give the hypurate. Why we are very willing about the glycine? Here we are not reducing the here we are not reducing the NS plus now. Why it is how it is reduced the NH4 plus ammonia. And here also you will find the phenyl butyrate will finally give you the what? Phenyl glutamine. So in any step, did you find any NH4 plus ammonia is required in any of this step? No, we didn't find. So how we will reduce the NH4 plus in this? How we'll reduce it? So the question is that basic question is that from where this NH4 plus is coming in our blood? It is coming from the amino acid. So it is coming from the amino acid, and here in this both cases the amino acid is required. Okay, in both cases what is required? Amino acid is required, and the most important amino acid, which is the glutamine, which gives you the glutamate, and finally glutamate gives you the ammonia and alpha ketoglutarate in the beginning videos we already seen. So finally the what is the important thing? Finally the ammonia concentration will decrease in our blood and the person can be cured. So there is a one more question. If deficiency of the N-acetyl glutamate synthase result in the absence of the normal activator of the carboxyl phosphate synthase, already we seen. So treated by what? Administrating the carboxyl glutamate, an analog of N-acetyl glutamate. So carboxyl glutamate if will give, then the enzyme carboxyl phosphate synthase will activate it. Or you can provide the other things like arginines, and also you can give the arginine in the diet, or the arginine in the diet. So this arginine will be provided for what? If other than that carboxyl phosphate synthase enzyme, one enzyme, other than that enzyme, if there is a lack in the ornithine transcarbamylase or arginosuccinate synthase or arginosuccinase, then you can provide the arginine for that. Okay. uh, this is all about the today's video. Hope so you enjoyed this video. Now just before going to finishing this class, we'll see the most essential and non-essential and conditionally essential amino acid. So essential amino acids are those amino acids in which cannot be synthesized in our body. We have to take from the outside of the uh, outside by the food. So like histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, valines are the essential amino acid. Non-essential, which are synthesized in our body, that are the alanine, asparagine, aspartate, glutamate, and serine. And the conditionally essential amino acid are what? Arginine, cysteine, glutamine, and glycine, and proline, and the tyrosine. Why it is called as a conditionally essential? So conditionally essential means what? These amino acids are synthesized in some of like one of our age or during one stage of our life, but later it is not synthesized. So conditionally essential is bonded. So this is all about today's class. Thanks for watching. We will meet in the next video. If you like these videos, just stay tuned with us. We'll meet in another video. Jai Hind.